Hello. This is Wooseok Kim, a member of Next Interface Lab at SIGCHI. Today I'm going to present our project. I won't go speechless. Design exploration on a real-time text-to-speech speaking tool for video conferencing. As we all know, the COVID-19 has sparked a demand for video conferencing. However, the suitable space for video conferencing is not enough to keep up with the demand. People sometimes had to attend video conferencing in the presence of other people. In a quiet public place, users might be hesitant to speak directly, of concern about disturbing those around them. Even in noisy places, users are hesitant to turn on their microphones, for concern that ambient noise will enter the video conference. Users may also be concerned about speaking security-critical information when people are around. Typically, text chats can be used as alternatives. However, where voice conversations take place, communicating via text chats can distract the attention of other interlocutors. Therefore, it may not be appropriate to chat alone in a video conference, where distraction issues are often noted. In this background, we investigated whether a TTS speaking tool could actually function as a new speaking channel. We were motivated by the following points. First, there is insufficient discussion to conserve user experiences from interference with the surrounding context. Second, there is not enough discussion on the need and experience of using AAC for people accustomed to speaking with their voices. Finally, there is insufficient discussion of proper TTS system configuration for real-time human-to-human communication. Here are 3 research questions. To answer these questions, we conducted 2 studies. In Study 1, we compared user experience based on the 3 speaking channels. Then, in Study 2, we tried to identify empirical challenges and user needs. A simple TTS speaking tool was developed as a web application. When a user types and sends a message, all other interlocutors can hear the synthesized voice. We selected one participant, PX, from each team, and we controlled spatial context and speaking channel for PX. All of the PXs used texting to communicate when speaking was limited, either using Zoom chat or texting what they wanted to say in a Google presentation. Based on the comparison of the 3 meetings, we found the following characteristics of text chat. First, text messages were more structured than messages delivered in voice, so participants were more quickly understood. However, text chat often lost effectiveness because others did not capture PX's chat on time. So the PXs did not receive other people's attention. Third, the interlocutors found it annoying to switch windows or shift their gaze to a narrow window. Fourth, the PX didn't know which interlocutors had read his text chats. So other interlocutors had to either say they had captured the text or read the messages verbatim to respond to the PX. Also, PXs did not consider other people's speaking turn. They completely ignored the turn-taking process and just text their messages. Some participants said it was selfish. At last, text chats had a weak presence, with some participants saying it seemed insincere to engage. In summary, text chat lengthened the meeting time, as others had to read the entire text, otherwise miscommunication occurred repeatedly. PXs became passive participants in conversations. They were frustrated that they couldn't get the attention of others when using text chat. However, the TTS speaking tool solved most of the problems with conversations over text chat. In the second meeting, all PXs preferred to use the TTS tool, because the TTS speaking tool instantly plays messages in synthesized voice. All interlocutors can see the message at the same time, without any extra steps. However, Study 1 was insufficient to understand the in-depth considerations for designing an effective TTS tool. Therefore, we prepared new probes that could stimulate users' perceptions and conducted the second study. The goal of Study 2 was to closely investigate the experience of the TTS tool, so we didn't compare experiences based on the speaking channels. The probe was modified as follows. This probe is still simple, but given the lack of discussion and few real-world examples of TTS interfaces, we thought it could act as a stimulus to give users a new experience. In this study, all participants took turns using the TTS tool. They took notes on their impressions and discussed them together. As a result, we found the following 8 challenges to utilizing TTS tools for real-time online conversation. First, using a TTS tool is affected by typing speed and speech synthesis speed, so it was difficult to take turns as quickly as speaking with voice. Second, there were silences while the user was typing, which caused misleading other interlocutors into thinking the TTS tool user's utterance was over. The TTS's insufficient expressiveness was also an issue. The TTS tool users naturally composed utterances in text style, but the TTS system did not adequately express them. The next challenge is about the psychological burden. Some participants expressed negative opinions about having their texts logged permanently. Siri-like voice, difficulty in distinguishing speaker, and sense of disparity in hearing third-party voices were other challenges. In addition to these challenges, we identified the following 7 user expectations. Because typing and turn-taking processes caused several empirical problems, participants suggested ideas for providing typing and turn-taking aids. Particularly emphasized expectation was paralanguage expressions. Participants strongly desired features related to emotional expression and back-channeling. Automation features, customizable voice, and non-invasive interface were also mentioned a lot. Despite the various empirical challenges and additional expectations, most participants agreed with the need for a TTS speaking tool in video conferencing. The participants said that they have frequently encountered speaking-restrained spatial contexts and could not properly participate in video conferencing. The participants also suggested other possible use cases in which the TTS speaking tool could be useful, as following figures. Then, how should the TTS speaking tool be designed? We originally planned to develop and test the final probe with further improvements. However, after conducting 2 studies, we found that its design can diverge in many ways, rather than converging on one optimal solution. We recognized that actual applications should be accompanied by further contemplation of the domain and service context. Finally, we proposed a total of 6 consideration points from 3 aspects. One of the most important considerations is how and what voice should be provided. Considering both user expectations and privacy issues, it is possible to develop a model capable of synthesizing voices, with low similarity to the users, but with a good identity, just as Apple's Memoji depicts a user's face. The users wanted to regulate the prosody of synthesized voices, as similar moods of other interlocutors. As a way to automate this, applying speech accommodation to the synthesis process may be considered. This should be investigated in detail, because there is no understanding of how users experience automated speech accommodation of their synthesized speech. Users expected TTS to properly represent their chat style. However, interpreting chat styles is not an easy task, as chat styles differ across languages and cultures. Rather, faster speech synthesis may be a more important issue for users. At last, we presented additional considerations on the user interface design. Our contributions are as follows. We found that only text chatting was insufficient to engage in video conferencing, where voice conversations were dominant. We suggested the possibility and usefulness of the TTS tool. We introduced the empirical problems, user expectations, and needs that may appear when using TTS tools. We suggested design considerations for a TTS tool.